Okay, page 42 and 43 is on our Ready Writing books. For our friends that are doing it at home, you're opening up the Class Kick assignment below. Okay, so our learning target, ready? We're going to research hydroelectric power and gather information I can use to write my informational article. Okay, so we're not going to finish this today. So we're just going to do page 1, answer the questions about your assignment, which we did yesterday actually. Yesterday. And then today we're doing pages 2 and 3. So we're going to read the article and study the pictures without highlighting. Okay. So first we're going to read the article and see what are some interesting information pieces that we can use in our writing. Marlene, mask above your nose. Okay, so hydroelectric power. So everybody finger on the title, hydroelectric power, so we can read it together. Are you ready? Reading together. Now on page 42. Ready? Okay, I have to be on page 42.
We do have to page 42, and then the page 4.
So then flip it back, so you can stay on page 42.
And then we're going to page 42. And then it goes back. My fault. Page down.
Okay,
You have to go like this the whole entire lesson?
I would love that actually.
No.
Okay, hydroelectric power. That is disrespectful. From the U.S. Geological Survey, ready? Hydroelectric power, how it works. So just how do we get electricity from water? Actually, hydroelectric and coal-fired power plants produce electricity in a similar way. In both cases, a power source is used to turn a propeller-like piece called a turbine. The turbine then turns a metal shaft in an electric generator. The generator is the motor that produces electricity. A coal-fired power plant uses steam to turn the turbine blades. A hydroelectric plant uses falling water to turn the turbine. The results are the same. How a hydroelectric dam works. So let's look at the pictures. Who wants to read bubble number 1? Dylan.
Water enters through pipes.
Good. Sophie.
Number 2.
What number 2?
Water turned into a turbine.
Propeller. Good. Marley, number 3.
Generator produces power, which is carried by power lines.
Good. Okay. What else do you see on that picture?
Water.
Water.
A trail race.
What was that, Bo? Words. Okay, what are the words saying? Penstock. Generator. Turbine. Trail race. What about the arrows? What are the arrows showing you? Dylan?
The wires from the power line.
The wires from the power line. Okay, so right here. So the wires connect to the generator and then go to the power lines. Cool. Okay, what about these white arrows? What are those showing you? Dylan, thank you for raising your hand. Which direction the water goes in, right? Okay, so it starts through here, enters through the penstock, moves through in this direction. So the water wants to go out somewhere, which causes the turbine to spin. So then as the water keeps spinning, as the water keeps making the turbine spin, it's moving downward and then out this way. Okay. Ready on page 43? Oh wait, let's go back to page 42. So using your pencil, let's highlight a few things, okay? So highlight in blue how hydroelectric power works.
We don't have blue pencils.
Okay, so which part of the informational article can we highlight that tells us how the hydroelectric power works? Yes, Dylan.
The turbine
The turbine
and the trail race
and the trail race
and the generator.
and the generator. Okay. Alejandro's not here either.
Okay.
Thank you. Okay, so we know it works in this direction. Okay. Yeah, you can highlight that. So here, go. Here.
Can I highlight?
Yeah, with your pencil.
Can I circle it?
Here. Ledger, are you okay?
We're on page 43. We're on page 42, sir.
Merlin. Okay. So next, let me scroll. Oh, that's not what I wanted. Highlight in green, but you in pencil, benefits of hydroelectric power. So what are some benefits with it? So reread over here. What are some benefits of the hydroelectric power? Dylan?
Power plants produce electricity in similar ways.
Cool. Okay, so they produce electricity. Highlight. Anything else? Dylan, what's another benefit?
Power sources.
Yes.
Produce electricity from coal-fired power plants use steam.
Yeah.
Oh.
Ariana? A benefit? So benefit is something good that you get out of it.
Wait,
Which one, Dylan?
get electricity from water.
Yeah, so we already said that it produces electricity. Okay, can we find any other ones then?
It uses falling water to turn the turbine, which powers the generator.
Oh, it's right
Right here, the turbine then turns, no,
Down on the bottom line.
right here. A hydroelectric plant uses falling water to turn the turbine. Is that a benefit?
Yes.
Is it something that we get out of it? It's just kind of explaining. We can highlight that for our explaining how it works.
Non-polluted.
Yes, Thomas.
I think it is.
Can you sit in your desk correctly? And your stool? Yes, Ariana?
Oh, I didn't know that was on the floor. Sorry.
Oh, you already have
Oh, okay. Okay, so now
Wait.
highlight in red/pink problems with hydroelectric power.
I don't think we
What
came
about this
across
one?
any problems.
Miss, I'll be what about this?
Can I just pick it?
Let me get a different color.
What about this
Yeah, we haven't
Right
come
here?
across any problems.
This one? That's just saying the same thing. Any problems? Does anybody see any problems with it?
No. It doesn't have a trunk I noticed
Thomas?
it has coal and coal will run out. It doesn't shrink.
Okay, so
Is it a coal-fired power plant?
Would it be done
Okay.
on
Thomas, we don't say shut up, because that's disrespectful. So you're saying right here where it says coal-fired power plants. Okay, so that coal-fired power plants are a problem, but it's not a problem for hydroelectric power. Okay? Okay, so we're ready to move on?
I guess.
Okay, let's go on to the next page. Marley, your desk faces this way, so your whole body needs to face me, including your chair. Thank you. Okay, so page 43 at the top. So we're going to read the article and then highlight in blue how hydroelectric power works, highlight in green benefits of hydroelectric power, and highlight in red or pink problems with hydroelectric power. Okay, so starting at the top on paragraph 2, a typical hydroelectric. A typical hydroelectric, ready? A typical hydroelectric dam is built on a big river with a large drop in elevation. The dam stores a lot of water behind it in the reservoir. Near the bottom of the dam wall, there is the water intake called a penstock. Gravity causes the water to fall through the penstock inside the dam. At the end of the penstock, there is a turbine propeller, which is turned by the moving water. The shaft from the turbine goes up into the generator, which produces the power. Power lines connected to the generator carry electricity to your home and mine. The water then flows into the river, past the dam. By the way, it is not a good idea to be playing with the water right below a dam when water is released. Yes, Thomas.
Some boy, he went in the water and then he drowned. And he's dead now. Because he did that.
Because he was playing in the dam?
And then he died. The
Is
water
he-
went, and then he drowned.
Yeah, if he drowned, then that means he died.
How would you play? Because there might
Okay.
have been not a water next to
Okay, is there anything that we should highlight?
I've drowned before. We played the dam.
That's scary. Dylan.
How did he drown?
Okay, highlight. Thank you, Dylan. I really appreciate that.
Where are we highlighting?
Highlight, Sophie.
My uncle pushed me in the water.
Thomas, to yourself. Okay. Anything else that we should highlight, Dylan?
The penstock got me called the water pump.
The penstock. Show me where it is. At the end of the penstock, right here? At the end of the penstock, there is a turbine propeller which is turned by the moving water. Okay. So this is information that you can put into your article, your informational text article, right? Okay, anything else?
The river that flowed into the water that flowed into the river past the dam by the waves and is not good to play in the water right below a dam.
When the water is released.
Yeah. I'm highlighting that.
Okay, you can highlight that if you're going to put that into your writing.
Okay, no, thank you.
Dylan.
Problem, benefit.
Power lines connect to the generator carry electricity to your home.
Okay, power lines connected to the generator carry electricity to your home and mine.
There's something in my mask. Can I take it out?
Okay, let's keep going. Paragraph 3, ready? The next title, read it out loud, go.
Pump storage. Receiving water from the peak electricity
Demand. Good, okay. Okay, on paragraph 3, ready? Demand. Demand for electricity is not flat and consistent. Demand goes up and down during the day. Overnight, there is less need for electricity in homes, businesses, and other facilities. For example, at 5 p.m. on a hot August weekend day, there may be a huge demand for electricity to run millions of air conditioners. But 12 hours later at 5 a.m., not so much. Hydroelectric plants are more efficient at providing for peak power demands during short periods than are fossil fuel and nuclear power plants. One way of doing that is by using pumped storage, which uses the same water more than once. Pumped storage is a method of keeping water in reserve for peak periods of power demand. Pumps move water that had already flowed through the turbines back up to a storage pool above the power plant. That happens when customer demand for energy is low, such as during the middle of the night. The water is then allowed to flow back through the turbine generators at times when electricity demand is high. Okay. Anything that we should highlight? Dylan.
Hydroelectric plants are more effective providing base power demand.
Okay. Hydroelectric plants are more efficient at providing for power. Oh, this is good now. Okay, pencil in your hand, let's highlight. Hydroelectric plants are more efficient at providing for peak power demands during short periods than are fossil fuel and nuclear power plants. Highlighting. Okay, anything else? Dylan? Any other important?
Less need for electricity in home, business, and facilities.
Here? So overnight there's less need for electricity in homes, businesses, and other facilities. Okay. Okay. Okay, paragraph 4. Anything we should highlight that has important information? Ariana? The first sentence? Pump storage is a method for keeping water in reserve for peak periods of power demand.
I don't think this thing has any problems. No.
Yeah, I know not read any either.
Except for it's not a good idea to be playing in the water. Well, the playing in the water is probably the only problem. And that's the problem.
Dylan?
The water is then allowed to flow back to the turbine generator that comes in is designed.
Okay, the last sentence, Muna.
Because if the human gets in here, for example, at 5 p.m. on a house obviously can be there, if the one is time for electrics to run millions of hours, 12 hours later, at 50 a.m., not hot, so hot, much.
Good. I like that as an example. So that's like a whole quote that you could use in your article. Good. Okay, we're gonna stop right there, okay? All right, go ahead and put your ready writing book